I will let Joe take over and begin his presentation on an overview of the ActivitySim consortium.
Great. Thank you so much, Li-Ming. And can folks see my screen and can you hear me?
Yep, it looks good, Joe.
Great. So thanks so much for inviting me to participate in this meeting today. I'm going to give you hopefully not too much of a technical background, but talk, starting this introduction with a little bit about what ActivitySim is. And if we can, let's see if I can just advance the slide. So what I'd like to do first is talk a little bit about the ActivitySim project and the ActivitySim partnership. As a project, developing activity-based model isn't anything new. Our field has been doing this for a couple of decades now, but the partnership aspect of it is really unique, and it actually has helped direct the project in I think, some very unique ways. I know many people on this call are already super familiar with activity-based modeling and its concepts, but I will spend a little bit of time just to make sure there's a foundation of understanding, hopefully across everybody, because I think that will also help kind of tee up some of the subsequent presentations. And then very briefly, we'll talk about some of the implementations that are underway with ActivitySim. So I'm going to start at like the biggest picture level here, which is what is the mission of the ActivitySim project? And ActivitySim is a project that's devoted to creating open source software, that's activity-based modeling software, that is reflects the kind of the best and most contemporary software development practices, and that we make available to the public and to public agencies or to researchers or private companies for that matter, for no charge. And just to, again, I don't want to, I know many of you are super familiar with this, with what activity-based modeling is, but I'll keep coming back to it just to make sure, again, we all have a shared foundation. What activity-based models, travel models do, are they predict the choices, the travel-related choices of households and individuals in a region. And it's typically been at a regional scale that we've been doing this, although there's nothing about the ActivitySim software that precludes anyone from implementing an ActivitySim-based model at a statewide level or even at a smaller level, a municipality or a county. And in fact, there is some work like that going on in the Bay Area. But when I say it predicts the travel-related choices, it's the kind of activities that people are choosing and households are choosing to participate in, the locations of those activities, the travel modes that they use to get there, the times of day that they're traveling, and a whole bunch of other dimensions to travel, as you'll see a little bit later in this presentation. I'm also going to cut to the reasons why I think that there are real benefits from the ActivitySim project. One is that folks who are participating in the ActivitySim project, agencies, individuals, get the benefit of the kind of shared expertise and the experience of a group. So, up to the prior to the inception of the ActivitySim project, many regions were developing activity-based models largely kind of independently. There might be, there was a kind of a very limited number of qualified, primarily consulting firms, although some researchers and academics were also developing such software. These qualified firms and individuals would develop these models in different regions around the country, and they were very limited in terms of their deployment. And each one was in a sense bespoke and kind of stood alone. And there were some limitations to that. One was that there just wasn't a lot of the ability to really kind of effectively communicate and to understand problems that may be shared across different regions. And similarly, and actually on a very related note, there wasn't the opportunity for one region to benefit or leverage from the improvements that might have been made in another region. What the ActivitySim project has been trying to do is not only have us all working from, have a forum and a structure for working from a common or with a common software platform, but also to be able to have a community where we can have an ongoing and kind of exchange of ideas. And I think that's something that, I personally really value about the project. We have, as I'll describe a little bit later, very kind of sustained engagement with each other and with the consultants who are contributors to the project. ActivitySim is also really stable. We've been really trying to develop it using contemporary, software development techniques, and there's a lot of people who are looking at the code. Presently, there's a bench of 3 different consulting firms. Joel represents RSG, which is one. Cambridge Systematics and WSP are also actively working on the development of the software. ActivitySim's pretty fast, and it's about to get a lot faster. We have been, seeking not only to make ActivitySim very kind of feature rich and responsive to the kind of policy and investment questions that all sorts of different agencies have, but also to be able to do so in a way that's not onerous from a runtime perspective. And then finally, ActivitySim is really less expensive. Rather than each agency or entity needing to go out and hire a contractor on their own, we pool our funds, and we're able, by virtue of that, able to kind of leverage our funds and get more bang for our buck. And I should say, at the outset, you'll notice that the slides that I'm speaking from have the kind of AMPO label logo. AMPO has actually been the Association of Metropolitan Planning Organizations, which is a nationwide organization to which hundreds of MPOs belong from across the country, has really been the kind of forum and the organizer through which we've been able to do this pooled fund effort. And so it really is an AMPO project. It's not owned individually by any entity. All of the work is open source under an open source license, and with AMPO kind of managing all of that. We've been really striving over the years of development to adhere to a set of principles. Number one, that we're collaborative, right? That we're talking to each other, that we're using common tools, we're speaking a common language, that we're cost effective. And, I was just talking about that a moment ago. Rather than have each entity, each agency, spending money individually, let's pool our money. Let's get the same, kind of bang for our buck, or more bang for our buck, because in many cases, we're doing the same things and we don't need to be paying for it 2 times or 3 times or 6 times. We want to make it practical. That, one of the limitations of activity-based models and their dissemination thus far into practice has been many of the large organizations have the ability, the large MPOs or state DOTs have the ability to have staff who are qualified and skilled and who are familiar with maybe more advanced techniques and data. But there's the complexity of the models, because they are more complex than traditional 4-step models, has been an impediment to the dissemination of these methods, which we think are much more responsive to the types of policy questions that we face. So we're trying to kind of lower the barrier to entry. They're extensible, right? We're always being asked new questions. So we want to build the software in such a way that it is kind of modular, and that as different regions have maybe their own particular questions or needs, that there's ability to accommodate that. And as I also referred to in the last slide, we really want to make it performant, right? We want it to be fast. It's a big waste of everybody's time to be sitting around waiting for model runs to be done. And we can just be, there's so many opportunities for us to be much more efficient in our computing, but that by extension makes us more efficient in the rest of our work as well. So how does the partnership work? As I said before, there's kind of 2 aspects. We're developing a tool, but we're doing it in the context of this partnership. So the way the partnership works is that agencies contribute annually to a pooled fund, and that AMPO, the kind of umbrella organization, facilitates this coordination and provides administrative support. So we're giving our money to AMPO, we're signing a funding agreement as an individual agency, and an MOA about how we're going to collaborate. And once agencies have paid their money into this, then they have the opportunity to help direct where the project's going. Ultimately, it was envisioned, it still is envisioned, that the project can be self-sustaining. But for now, the kind of merit and the ability to direct the project is basically saying, if you're willing to contribute funds, then you're able to have a seat at the table. Of course, we always welcome new agencies. It allows us to have new perspectives. It also gives us more resources with which to make investments in features or in performance. And thus far, I think we've been pretty successful. It's about 8 years that the group has started. We started with just 3 core agencies, and now we're up to 10 agencies, and we expect that more will be joining in the coming year. How does this functionally work? Well, the work on the agency side is really led by what we call the Project Management Committee. And in fact, I'm speaking to you on behalf of the Project Management Committee as I'm the chair of that committee. The PMC is actually comprised of the agency staff. So each agency, in a sense, kind of gets a vote to help set the development priorities and to provide that kind of technical direction and oversight to the project. But really, we welcome as many individual agency staff to participate in the meetings. When it comes to decision making, we try and make sure everybody has an equal vote. But some agencies might have 3 or 4 people regularly attending meetings, because when you're in on the ground floor and you can see how the software is being developed, it just increases the likelihood that it's going to do what you need it to do, and it increases your knowledge, staff's knowledge of what's, what we're doing. We are trying to both have a really solid core to the software, but also implement new features. And there's always a balance, right? We want to both expand what the software can do, but make sure that we're kind of taking care of the foundational stuff as well. The PMC helps us identify and respond to kind of these new policy and investment analysis needs, as Jilan and Joel will talk about later. And we've generally been doing this on an annual basis. So like every year, we have a set of money that we can share or spend on consultants, and we go through an annual process of saying how we'd like to spend that money and allocating it. And it's a highly collaborative process. Presently, I mentioned there's like 10 MPOs, 10 partners, not MPOs. 8 of them are, or I should say 7 of them are MPOs. 1 is a county transportation authority, San Francisco, who I represent. And then there are 2 state departments of transportation, Ohio and Oregon. So I know that many of you, as I said before, are super familiar with activity-based models and what they do. And so I don't want to waste anybody's time. But for those who maybe aren't super familiar with activity-based models, I'd like to give at least a 30,000-foot view, because I think that may provide some additional understanding as some of the later presenters talk about it. Activity-based models, like historical or traditional 4-step models, are really predicting the demand for travel. That's what the core of ActivitySim is doing. As I said earlier, it's talking about the participation in activities by households and persons, where those activities happen, the travel modes, the time of day, and a whole bunch of other choices, as I'll show you on the next slide. The data inputs, there are, in some cases, very strong commonalities with traditional 4-step models. For example, spatial units like travel analysis zones that might have information on population or employment or other land use attributes. Just like 4-step models, we accept or need information about how the network performance or level of service by mode, including zone-to-zone travel times and costs and numbers of transfers and so on, by mode, by time of day, and by origin and destination. What really distinguishes activity-based models is that they are working at a really fully disaggregate level. So a key differentiating input is the presence of a synthetic population. And the synthetic population is basically a list of synthesized people and households that represents all the folks who live in a given region or any spatial unit, along with all of their key attributes. If you've got a household, it's got 5 people, you have 5 records for the 5 people in a household record, and the ages of those people and the income of the household and their worker status or student status and so on and so forth. And this really unlocks the ability to do a whole bunch of other things. One, it helps mitigate aggregation biases, which are often found in more traditional aggregate models, but it also really unlocks the ability to do much more detailed kind of equity analysis, like who is this affecting very specifically. And because these foundational units are individuals and households, the behavioral assumptions are a little bit different. So we still estimate models that in many ways have analogs in an aggregate four-step framework, but there are some differentiating features like the ability to introduce individual level attributes. So, most of the models in the ActivitySim, but not all, are discrete choice models, just like you see in many, but not all four-step models. Again, it's fully disaggregate. And what ActivitySim generates looks very much like a synthetic travel diary, right? Just like you would collect this data on what households and individuals are doing, then the model will produce essentially a household diary that will, of course, is first calibrated to a base year condition, but then can be used to, determine the effects of land use changes, network changes, policy changes, investment changes, and so on. Here's a little bit more detailed information. For those of you who are obviously, everyone on this call is familiar with the kind of general sequence of models, you can probably see that there are some commonalities between an activity-based model and a traditional model, including, say, for example, things like maybe auto ownership or generation of activities, and then the subsequent choosing of destinations and mode. But there's lots of other stuff that's in here too. So, for example, most start with calculating a set of accessibilities that can then be used in downstream models, predicting usual work and school locations, household auto ownership, activity patterns. So again, these are a little bit more detailed than you would see in a traditional aggregate four-step model. And in fact, these are the types of detailed information that you typically actually might find some difficulties in maintaining in a four-step model, just because there's so much detail. So in ActivitySim, just for example, there's about 8 different activity purposes that are represented, and some of these are in fact even further disaggregated, including things like eating out and shopping. The modes are relatively detailed, including, obviously all of the kind of drive and transit modes, TNCs. These are all highly configurable to the conditions of a particular region. So, for example, PSRC may have ferries as a unique mode, and another region might have a different set of modes. But again, it's all, the core remains the same, but the modes that are used are configurable and customizable to a particular region. You'll see here the temporal resolution is far more detailed. And this is obviously both to accommodate the ability to represent the way that people have a kind of complex set of activities that they participate in, but also unlocks the ability to do things like integrating it ideally with more detailed network models, like DTA, dynamic traffic assignment, or potentially even bringing back into ActivitySim more detailed representations of how network levels of service change over time. And one of the other key attributes of the ActivitySim model and other activity-based models is that they really can accommodate much more detailed spatial resolutions. So, for example, while we do use traditional travel analysis zones, say, for example, for generating auto, travel times from origin destination by time of day, many of the implementations are now using things like called microzones, which can be, something like a census block, or even some model implementations, even down to an individual parcel level. So you can get much more kind of fine-grained representation of what's happening at a local level. Some of the versions of ActivitySim use transit access points, which is another kind of way of building in some greater consistency and sensitivity between the transit choices and the transit costs and the core demand models. It's one of the things that is neat about ActivitySim is that it's primarily implemented in Python. It can be run under any of the major operating systems. The hardware requirements that might be required for any individual implementation are really driven by a couple things. One, how much spatial detail you want to build into the skims or the zones, and the population. And we try and, for the issue, in the interest of expediency, try to keep everything in RAM to the greatest extent possible. And just as an example, so in the SANDAG implementation, and SANDAG has actually implemented 3 different flavors of ActivitySim. It takes about a couple hours to do a 100% simulation of everybody in the population, in that synthetic population. And we actually, in the coming 2 or 3 months, we expect that runtime is going to be cut something more than in half. So it's very kind of speedy software, and we expect that with our continued investments that those runtime benefits will continue to improve. There are a bunch of ActivitySim is being implemented in a number of different regions now. I describe them as current, underway, and planned. So in some instances, there are fully stood up versions. You're going to hear about one of those in a subsequent presentation for SEMCOG, but other regions also have fully stood up versions, including ARC in Atlanta and SANDAG in San Diego. I believe there are other implementations that are also well underway as well, and may even be called, kind of complete. I don't want to speak for all of them, and other folks that are just starting to get started on their ActivitySim implementations. And I should say, with all but one exception on this list, all of these folks are actually participating in our calls, which we have about twice a week, when we meet with everybody, talk about technical issues, talk about admin issues. So we really have a high level of engagement with each other. I should say participation in all these meetings is not necessarily required. It's optional, but it does help facilitate the building of the community. I want to stop after, I think, this next slide. We're just in the process of wrapping up we call it phase 6B. As I said, we've been trying to do these on an annual basis, and just about to initiate our phase 7 work. I'm happy to talk to you about where we are and where we're going in this next year in any kind of subsequent discussion. But really, our path is to continue our implementation and improvement efforts, making the software more performant, easier to use, and more sensitive to the types of policy questions that folks have. I want to give just some context here in case you want to reach out to anybody. Bill and Caitlin at AMPO have been instrumental in helping facilitate this project from an administrative standpoint. Of course, you can always reach out to me as the PMC chair. I'm happy to talk about the project. But we actually have 3 consultants who are incredibly well qualified and bring just so much to the project. You're going to hear from Joel from RSG today, but also Clint Daniels at WSP and Jeff Newman at Cambridge Systematics. And I would encourage you to reach out to any of us or any of the partners if you have any interest in following up. So I went a little bit over 20 minutes. I'd like to maybe stop there, and I'm happy to take any questions.
Okay, any questions for Joe? There is a chat box. I'm sorry, I've not been monitoring yet. That's fine. Questions for Joe? Well, maybe some other people coming up with questions. I have one. You mentioned about that ActivitySim will be getting faster in near term. What are the improvement that's underway in terms of the performance that you have in mind?
Sure. And, there have been, as I said, that the software has been primarily implemented in Python, and there are certain calls that are made within that framework that are computationally expensive, specifically the eval. And as you can imagine, these tables get really large in Python, and there are basically repeated calculations over and over, repeated evaluations of expressions. And so one of the contractors, Jeff Newman at CS, has actually implemented a way that's in order of magnitude faster to do that with this library that he has been developing that's going to become part of the ActivitySim project. There are also some other implementations and changes that he's made kind of behind the scenes in terms of how we access skim data and how we do certain other kind of under the hood operations. And the combined effect is that we expect something like a 60% reduction in runtime for ActivitySim, and there's a whole set of downstream improvements that we're also that are on the table to further reduce that.
Nice, thank you. Chris.
Thanks, Leming. Hey, Joe. Sorry if I missed this, but have you all experimented with cloud resources? And could you, if so, could you speak to sort of successes and issues with respect to implementations in the cloud?
We haven't gotten too far into the kind of cloud deployments. It's entirely possible. I know that individual developers, RSG, CS, I don't know the extent to which WSP all have spun up versions that are operating in the cloud.
Okay.
That really hasn't been a core focus to us, in part because, up to this point, and in fact, based on some of the experience that others have had, that there can be, although some of these problems are going away with respect to maintaining the other side of the, component, the network side, which you also need to have operating in the cloud unless you want to be throwing data, back and forth a lot. But also there have just been kind of cost effectiveness questions, particularly if you're running the models, hundreds and hundreds of times. It can get pretty pricey to do that. So at this point, entirely possible, done. A lot of the work that RSG was doing in development and testing initially was done in the cloud, and it certainly benefits, as you can kind of distribute, more widely across more and more processors. While there may be a ceiling, there are also benefits to that. But so far, that hasn't been a core focus of our implementation work.
Okay. So all the runtime improvements are coming sort of from the code side. And
That's exactly right.
Okay. Great. Thanks.
If we have time towards the end, we can probably still open up for more questions.